Hello, and welcome to this edition of Coffee Chat with Cricket. I'm Kripa Srivatsan, Director of Product Marketing at Infoblox, and I have with me Cricket Liu, Chief DNS Architect at Infoblox. Thank you, Cricket, for joining us today.
Of course, Kripa wouldn't have it any other way.
Awesome. Yep, we have a lot of fun in these coffee chats. And I'm really excited today to talk about a new exciting offering from Infoblox called BloxOne Threat Defense. We recently announced it. It's live. It's available to customers today as we speak. And BloxOne Threat Defense is the industry's first hybrid security solution that leverages DNS as the first line of defense. And as customers or you followers of Infoblox, you may have heard of products called ActiveTrust or ActiveTrust Cloud. BloxOne Threat Defense is a revamped, rebranded solution that combines the benefits of ActiveTrust and ActiveTrust Cloud for a really ubiquitous hybrid solution that can protect devices and users anywhere, leveraging DNS as we talked about. So as we go into this topic, we'll cover some of the benefits, what is in it for customers, and how does the architecture work? Why is it unique, and what can it offer to customers as opposed to some of the, how can it augment some of the other security solutions out there? So Cricket, let's talk about the architecture of the solution. I know it's a hybrid model. We have a cloud-based, cloud-managed service and cloud-based components. We have on-premises components as well. So can you give us a little bit more information about the architecture? Sure.
So the cloud-based components are basically a recursive DNS service in the sky, if you will. High-capacity recursive DNS offering that's also secure. And the idea is that if someone sends you a query for a domain name that we know to be malicious, or that through analytics we can determine to be malicious, we can block that resolution from happening. So that's really powerful, and it also gives you a configurable resolution policy. So, for example, if you want to protect some of your employees from certain types of content out there on the internet, you want to prevent them from going to phishing sites, you want to prevent them from accidentally resolving botnet command and control channels, things like that. You can determine what they can and what they can't resolve. Right. But I think there are two really interesting things about it that set it apart from other offerings that are sort of secure cloud-based recursive DNS. One of them is, as you said, the hybrid nature, which is that there are on-prem components too. In many cases, in order to use somebody's secure recursive DNS service, you point your device's stub resolver settings at the IP address or IP addresses of the service, and you just use it that way, and you get some sort of generically secure DNS resolution. With ours, you have the ability to do that, but you also have the ability to integrate your on-prem DNS infrastructure with it. So you can do that with Infoblox's NIOS, which is our very successful DDI platform. And you can have it use BloxOne Threat Defense, use it as, for example, a forwarder and get security that way. Or you can have relatively small, usually VM-based instances of recursive DNS servers that we call DNS forwarding proxies that then forward up to BloxOne Threat Defense and get their security that way. Right, right. And I think the hybrid approach leverages or enables organizations to leverage the scale of the cloud, right? You can detect a lot more threats using analytics, things like that. But you also stay close to the on-premises ecosystem, right? So let's say the customer has Infoblox DDI, they get better visibility into those infected devices, which end host is making that malicious communication. You can also integrate with the rest of the on-premises ecosystem. So I think that's that hybrid approach really gives you kind of best of both worlds, so to speak. Yeah, it's a challenge, I think, in some cases for these cloud-based recursive services to, I would say, triangulate to the individual client that actually sent the original query for a malicious domain name. Because in most DNS architectures, what happens is the iPad, iPhone, laptop, or whatever is configured to query a local recursive DNS server. It might forward to an internet forwarder that does internet domain name resolution on its behalf. it in turn might forward up to some cloud-based recursive DNS service. By the time the cloud-based recursive DNS service actually sees the query and can identify the domain name in the query as malicious, it just thinks it came from the IP address of the internet forwarder.
Right.
It no longer knows the IP address of the client that originally sent the query.
Right, exactly. So that kind of visibility is lost.
That's right.
If you're using a cloud-based only solution. And I think the other important thing is east-west traffic, right? Lateral movement of threats, or that type of scenario, you cannot really detect that if it's a cloud-based service only. You need something internal in the network. So the on-premises kind of DNS security solution can detect that east-west traffic and movement of threats within the network.
Right. It's still important to have that kind of data because, for example, if you detect that there's been a compromise on your network and you can identify the machine that was compromised, one of the things you want to determine is once the attackers gained access, where did they go? What other systems internally did they attack? Were some of those compromised? Do I need to then clean them up?
Right, exactly. Great points. Before we move any further, we did ask our registrants to send us any questions that they have that they would like us to answer live in the coffee chat. So I know we've got a bunch of them.
We do.
And if you haven't already submitted questions, please do that live as we are progressing through the session. And we will get to as many questions as we can because we do want to keep this about what the audience wants as opposed to just talking about Infoblox.
Yes, well, that's what makes it fun.
That's what makes it fun. So maybe we can take some of the questions that have come through.
Yeah, absolutely. So one of the questions had to do with integration, and in particular integration between Cisco's ICE and Infoblox. And is there a way to integrate, for example, BloxOne Threat Defense with ICE?
Right. So absolutely. So Cisco ICE is a NAC solution, as people know, and one of the things it does is set policy as to what devices can join or cannot join the network, right? So we do have integrations with Cisco ICE, and what we do there is, let's say there's a rogue device or a new device that's joining the network, and you want to set policy that says every time a new device is trying to connect to my network, I want to have it scanned. I don't want to allow it until it's been scanned and deemed, safe to join the network. So because Infoblox is the IP address management solution, it knows when it has to give out an IP address, it knows when a device is trying to join the network. So we can send an automatic notification in real time to the Cisco ICE solution. So now it can say, okay, I'm going to not allow it on the network until I deem it to be safe. Same things with malicious events. Let's say our BloxOne Threat Defense detects a malicious DNS activity. We can send real-time notification to Cisco ICE, which can then say, okay, this device is doing something malicious, so I'm going to knock it off the network and not going to allow it until it's been cleaned up. So these kind of two use cases are very popular for companies that our customers leverage.
Okay, that's great. That's great. Someone else asked, how does this new service coexist with firewall solutions? Why do we need to implement this feature with DNS if we already have firewall rules implemented? And I think that's an interesting question because there are a number of differences, but I think superficially it probably seems like there's some overlap between the functionality.
And we get that question a lot, right? So firewalls are great to protect the perimeter. Right? They're built for deep inspection, things like that, and they're great at what they do. But when you put in a DNS layer security, you can actually offload a lot of the work to block known threats at the DNS level. So you can block a lot of the known malicious attacks like ransomware, phishing, things that we already know are bad, right? We can block at the DNS level, so the next-gen firewall can focus on more deep packet inspection. So you can actually give back processing power to a next-gen firewall, for example, when a customer leverages DNS-based security, right? And so that's one thing. The second thing is we can add to the threat intel that the firewall works off of. So, for example, as you know, Infoblox, creates and generates and aggregates large amounts of threat intelligence, right? Including newly observed domains, right? Including DNS-specific threat intelligence. So customers or organizations can leverage that in a DNS solution like ours. They can also put that same threat intel into a next-gen firewall to take further action and block it at that level. So it's really complementary. I would not see it as one or the other. It's like having DNS layer security actually makes next-gen firewalls even better. It improves the ROI on the next-gen firewalls, definitely.
Yeah. Well, I think that the point that I made before about triangulation also holds with firewalls,
True.
doesn't it? Because in most cases, in most organizations, the firewall is at the perimeter of the network, out at the periphery. And again, like with the cloud-based recursive DNS services, by the time it sees a query, even if it's a next-gen firewall that has the ability to identify a query as potentially malicious, it doesn't really know where it came from.
Exactly.
All it sees is, okay, this query is headed out to an authoritative DNS server on the internet from the last hop internet forwarder.
Exactly.
So triangulation is an issue, and then you also have, I think, an issue. I'm told of the number of indicators of compromise, the number of malicious domain names that a firewall can hold. And I'm told anyway. I'm not an expert on next-gen firewalls, but I'm told anyway that it's a somewhat limited number. It's in the hundreds of thousands, and in some of our threat intelligence feeds, we've got millions of domain names, and you'd rather not be in the position of having to sort of pick and choose which threats you're going to defend against.
Right, exactly. And as you know, I mean, a DNS appliance, even a mid-range DNS appliance, can consume millions of threat indicators and act upon 20, 30, even 40 million indicators, depending on the size of the appliance.
Right.
So that's a lot of threat intel that we can act upon, right, and block. Right. So definitely nicely complements the next-gen firewalls. Yeah. So I would not see it as either or. It has to be both, right?
Yeah. So somebody is also asking about the applicability of the solution to IoT, Internet of Things security. Yeah. I think that's an interesting question because, of course, IoT is much in the news lately. But I personally, when I look at the challenge of providing IoT security, I think, well, one of the things we have to resign ourselves to is the fact that we're probably not going to be able to put some arbitrary piece of endpoint security software on the IoT device, right? And so we're going to have to provide the security in some sort of a passive fashion via the services on the network. And there, I think that DNS is really well suited.
Absolutely. So like you said, not all endpoint or IoT devices lend themselves to have an endpoint agent deployed on them, right? Many of them are non-standard devices running non-standard protocols, right? And they're lightweight devices. Mm-hmm. So, but many IoT devices are IP enabled, or if they're not, they connect to a gateway, IoT gateway, which is IP enabled, which means they're using DNS, right, for connectivity. Mm-hmm. So when you put in a layer of defense on the DNS server, like you said, it kind of covers that whole IoT deployment, so to speak, right? And it can prevent things like botnet formation by these devices. Like we heard maybe 2 years ago, connected cameras were forming botnets, right? Mm-hmm. It can prevent like data exfiltration that could be coming from these IoT devices and going through DNS. So like you said, leveraging DNS as a common foundational architecture to protect IoT deployments makes a whole lot of sense.
Yeah, I think it really has advantages because, of course, virtually everything out there that's going to conduct non-trivial transactions over a TCP/IP network uses DNS in order to do name resolution. So whether you're talking about IoT devices or something even more exotic, DNS is sort of the lingua franca of the internet. Everything has to be able to speak DNS in order to then do its business over the network.
Right, exactly, absolutely.
So that's a big advantage.
Yeah.
Somebody asked about our integration with Akamai's Fast DNS. Okay. And I honestly had to look this up because I didn't know what Akamai's Fast DNS was off the top of my head, even though I was sitting 2 chairs down from Larry from Akamai on Thursday of last week. And he's the guy who actually sort of runs a lot of the DNS operations over there, which are pretty extensive. But I did find out that FastDNS is really their authoritative DNS offering. So it's a service that you would use in order to host internet-facing zones out on Akamai's authoritative DNS servers. So there's no direct integration between that and BloxOne Threat Defense, which is a recursive offering, right? I mean, recursive offering is out there to look up domain names on your behalf, and in our case, to try to determine whether or not the domain name you're looking up or the IP address being returned from that lookup are potentially malicious, and whether it should be passed back to you. Authoritative DNS is about making sure that if somebody using a recursive service is trying to look up the IP address of your web server or your mail server or something like that, that it gets returned and hopefully gets returned quickly. So any integration that we have with Akamai's FastDNS would be integration between, for example, NIOS and FastDNS. So you could, for example, use NIOS to manage a bunch of primary zones and then have them transferred to FastDNS for propagation around the internet, advertisement via their authoritative DNS infrastructure. But I don't think that there's any integration directly between BloxOne Threat Defense and FastDNS. So I hope that answers your question.
That's right.
Somebody asked, how is this different from Active Trust?
Okay, great question. So Active Trust and Active Trust Cloud were the names of our security products up until recently. Active Trust was the on-premises DNS security solution that we offered to customers, and then we also had a SaaS-based pure cloud-delivered solution called Active Trust Cloud. What we did with BloxOne Threat Defense is we combined the capabilities and the power of both of these offerings into one kind of seamless hybrid solution, so that they work together as one, so customers don't have to decide, okay, do I need the cloud, do I need the on-premises? They can leverage the cloud, like I mentioned earlier, for better scale, detecting more threats, and they can still stay tightly integrated with the on-premises ecosystem, get better visibility, like we talked about, send notifications to a Cisco ICE or their SIM solutions on premises or the sandboxing, whatever it is, right? So you're kind of leveraging the best of both worlds by leveraging the hybrid solution. And the other important thing about a hybrid offering is that a hybrid solution gives organizations that resiliency. Let's say for whatever reason you lose connectivity to the internet, right? Now your devices are unprotected, right? So when you do leverage a security, a hybrid security approach, your on-premises DNS security will pick up, right? And it'll start protecting all the devices. So you're kind of protected, whether you're connected to the internet or not. So, it gives you that resiliency when you leverage a hybrid solution. So that's essentially what BloxOne Threat Defense is.
Yeah, and I think it's important, we didn't say this explicitly, but I think it's important that you can have a security policy implemented on-prem that is the same as the security policy that's enforced to people who are roaming.
Exactly.
And that I think is challenging to do if you're looking at somebody else's DDI solution and somebody else's cloud-based recursive service.
Exactly. That's a great point you make, Cricket. So you want to make sure that your users in your headquarters, your data centers, remote offices, users who work from home, you want to make sure that all of them have the same level of protection. And like you said, if you have a seamless hybrid offering from one vendor, you cover that, right? As opposed to piecing together different solutions from different vendors, absolutely. And we keep getting asked, okay, what do you protect against, right? We keep talking about DNS level protection. So you can protect with DNS security, you can protect a lot of the things like your modern malware, right? 90% of modern malware uses DNS to connect with this command and control server. So you can protect things like ransomware, phishing, exploit kits, you name it, right? Many of these known threats, we have them in our threat intel feeds. We can block DNS resolutions to those destinations. But the other thing that's a gap actually in other security solutions is detecting DNS-based data exfiltration, right? And because Infoblox is a DNS server, we know what a good DNS query looks like and what a DNS query that's hiding some data looks like, right? So we're able to make that distinction. Of course, we have analytics-based models, we have machine learning-based models that can not just detect known DNS tunneling, but it can detect also like zero-day threats, right? Things that not necessarily are going to a destination that's classified as bad yet. It may not be in any threat feeds, right? So, but you want to make sure that you can detect that as well. So I think our models really do a good job of detecting that. And of course, DGAs, which is probably not that, maybe people may not be familiar with it, but domain generation algorithms and the counterpart to that fast flux type of threats. Those are some advanced threats that where you need analytics, especially DNS-based analytics, to detect them, and that's something that BloxOne Threat Defense provides as well.
Right. I think that's important because reputation-based security only will get you so far. Right. If you have to have seen a domain name before and assessed whether or not it's benign or malicious, that's fairly limited because, for example, anything that looks like DNS tunneling, well, you've probably never seen the query before because it's never existed before. In fact, it doesn't really exist, right? It's just data that's encapsulated in DNS queries or in resource records being returned in response to DNS queries. So you have to have analytics on the back end. You have to have the ability to actually catch that stuff on the fly, subject it to analytical algorithms and say, look, I'm going to do entropy analysis or n-gram analysis or any of those things that I don't understand very well, but to automatically detect that sort of malicious activity from its fingerprints rather than some predetermined reputation.
Right, absolutely. I think that's an important point. And the topic of SD-WAN also comes up quite a bit, right? I think I read a Gartner report that said that by end of this year, maybe 40% of organizations are going to have SD-WAN enabled branch offices, right? So these are branch offices that are directly connecting to the internet. They are not hairpinning traffic back to the data centers, right? The direct internet breakouts. And it's too expensive to replicate their full security stack that they may have in their data center or headquarters in these branch locations, right? So how do you secure those branch offices? And again, DNS-based security, BloxOne Threat Defense, can help that provide that first line of defense in a cost-effective manner, right? It's easy to implement, it's easy to configure in minutes. If you don't want the on-premises components in those SD-WAN branches, leverage the cloud, right? So point the DNS queries to BloxOne Threat Defense in the cloud, and you can protect those branch offices like that. It's quite easy and it's very cost-effective. So I think that's something that people can start thinking about as they deploy SD-WAN.
Yeah, we've had some conversations. I've been involved in some conversations with some big SD-WAN vendors, and one of the things I didn't realize was that in many cases, the SD-WAN devices that are out there at those branch offices are pretty resource poor because we've talked about, hey, what about the idea of running a small DNS server with these threat feeds and things like that on these boxes? And they go, well, we don't really have the horsepower for that. So in a case like that, being able to use that local internet breakout and hit BloxOne Threat Defense and get a little bit extra security actually makes, I think, a lot of sense because you're probably, if you don't have enough oomph, enough horsepower on the SD-WAN device to run a little DNS server, you probably don't have enough horsepower to run a next-gen firewall either.
Exactly.
So you've got to sort of take what you can get.
Exactly.
Yeah. Well, let's see what else we've got. Do we still have any coming in? Let me see. We had. How many of your solutions can be made autonomous? That is, can they operate without your intervention? So I think this has to do with maybe automation.
Right. Yeah, so I think from a protection perspective, BloxOne Threat Defense and all our DNS security solutions automatically blocks malicious requests that are going onto the internet. So that blocking is automatic. If you want to just log and monitor the customer, you can configure it that way as well if you don't want to immediately block it. And a lot of the notifications to the ecosystem, right? So like we talked about triggering a Cisco ICE, for example. Or you can also, with our ecosystem integrations, we can trigger a scan from a Rapid7 or a Qualys or a Tenable, like vulnerability scanners. That can be automated as well. So it depends on how much automation you want as a consumer. And obviously we provide configurations in such a way that it's up to the user to decide how much automation he wants, right? And how much of a human intervention he wants.
Right, so they get to determine whether they want to have some sort of automated response to the detection of malicious activity or whether they want to have a human in the loop to say, yeah, that looks fishy, let's turn off that port or quarantine that device or what have you.
And then the other important thing about automation is security operations teams, right? Now these are the guys who are burdened with the task of finding out once a breach has happened, what happened, and how soon can they detect it, how soon can they correlate the information and start the remediation process, right? And we all know that security operations teams are short-staffed. There's a global skills shortage. They're having to do more with less every day. And the more automation we can provide to our operations teams, the better, right? So one example where we can help with that is in the BloxOne Threat Defense, there's an automated threat investigation tool called Dossier. So this tool, what it does is typically threat analysts will go to different sites on the internet to find out whether a particular indicator of compromise is malicious or not, whether they should block it, right, in their firewalls or whatever other devices. So, but they do this manually right now, right? They go to 10, 12 different sites, and then they kind of correlate the information, copy paste in different places, and then kind of make a decision. With the Dossier tool that's part of BloxOne Threat Defense, all of that data gathering is automated. It automatically goes to dozens of sources on the internet to get that information about a bad URL or IP or a host name. And then it can provide all that information in one place. So now the threat analyst is looking at all this information, and now he can make a decision fast, right? He gets contextual information about those indicators of compromise. So that's another example of where automation is a huge benefit for a SecOps person, for example.
Yeah, it sounds like it. So they get that aggregated view of data that maybe derived from lots of different sources.
Right, exactly. And the other thing they can do is put that information into a SOAR tool. So DDI data, DNS, DHCP, and IPAM data provides a lot of context about the infected device, right? Metadata about what type of device it is, where it is in the network. Is it a financial server? A financial server, you want to make sure that thing is cleaned up fast, right? So when the security ops team has all this information, they can now populate their SOAR tool. Let's say they're using a SOAR tool. They can put that information automatically, and now that SOAR tool can work with the rest of the ecosystem to remediate. So I think those are important aspects from an operational side of the house. Yeah.
Okay, good. Someone asked, how do we track which inside hosts are performing lookups to malicious and newly registered domains? I think that really has to do with the hybrid approach, right? Because again, I think he's looking at two different things. One, how do you detect that somebody is looking up something that is, for example, a newly observed domain or something that's known to be malicious? And second, how do you figure out who it is? So there's the triangulation aspect of it. And certainly there are lots of different ways to do that. One is that you can plumb response policy zones like a newly observed domain's feed into your on-prem DNS infrastructure, and that way, you'd automatically see if somebody looked up a brand new domain name. And we offer newly observed domains feeds from different sources.
Right, that's right.
Including Farsight, I believe.
Yep.
Farsight is probably best known for having a newly observed domains feed. You can plumb that into your DNS infrastructure, anything that supports RPZ, and then as long as you have that configured on your local recursive DNS servers, you'd automatically pick up the IP address of the DNS query, or the endpoint basically that sent the query in the first place.
Yep, absolutely.
So that's what we would say. That's certainly one way to do that. If you didn't have an extensive on-prem DNS infrastructure, you could still do that using BloxOne Threat Defense by having, for example, a DFP, a DNS forwarding proxy on-prem, or something like that.
Right.
Yeah. This one's a little off the beaten path, a little different from the ones we've been answering. How can we prevent end devices from communicating with rogue DHCP servers? So I think there, we might actually have to flip that around a little bit. DHCP, of course, is broadcast-based, so it's a little bit difficult if you have a rogue DHCP server on your network. It's difficult to prevent it from hearing a DHCP broadcast from a DHCP client on the same subnet in the same broadcast domain. That's sort of a fool's errand. But on the other hand, there are different ways to detect the presence of a rogue DHCP server on your network. There are sort of standard tools like Wireshark and TCP dump and things like that you can use to catch the communications from the DHCP server, and then for example, find out his MAC address. And if you find out his MAC address and you have a DDI solution like ours, then you can figure out what IP address that is. And potentially, if you have network insight, what port it's on, what switch it's on, and then you can knock it off. And I did a tiny bit of research before this, because I remembered that there were also features in certain managed switches and other types of layer 2 devices that you can use, or layer 3 devices in some cases, that you can use to prevent rogue DHCP servers to snoop on DHCP traffic, basically, and say, I'm sorry, you don't get to participate in DHCP on the subnet.
Right. Okay. That's great.
Yeah. Let's see. And then another question we got was, how do you see current firewalls augmenting DNS services by adding to it? And then secondly, apart from resolving operational issues, how much of a critical role do these tools from Infoblox play in preventing successful attacks?
Okay. So that's an interesting question, right? So from the firewall perspective, let's answer that first. Like I mentioned earlier, we can augment the threat intel that firewalls use with the stuff that we gather and we put into our DNS servers. So things like newly observed domains, DNS-specific threat intel, we can augment the threat intel of a Palo Alto box, for example. So that's one aspect. And then the other thing is, like I mentioned, when you put in DNS security inside the network, then you're kind of offloading a lot of the work from a Palo Alto or from a next-gen firewall. So then it means that they're able to spend the processing power on doing more advanced inspection on the traffic and things like that, as opposed to just working on these, trying to block all these known bad things that can be done inside the network and not necessarily at the perimeter. So I think that's how kind of DNS security and BloxOne Threat Defense can really complement a next-gen firewall. And then the second point was about, what was the second one? How do we prevent attacks? What role does Infoblox play in preventing attacks? So there's a good example for that, right? So let's say there's a CNC destination that's associated with ransomware, right? Typically, how the ransomware works is once it's breached the network, it's taken advantage of the initial vulnerability, and a device is now infected and it's inside the network. Typically what it does is it'll try to connect to its command and control site to download the encryption software, using which it will lock up all the data on the device and then ask for a ransom. So when we know that that destination that is trying to connect to is bad and we block the DNS resolution, it will not be able to download that additional encryption software and start the encryption process. So we're kind of proactively preventing, like a ransomware from taking over your device. So that's just one example of how blocking bad DNS resolution can prevent actually spread of attacks and threats inside a network.
Right.
I'm sure that there are many, many examples, but that's just one way how a DNS security solution can prevent attacks.
Yeah, and I think even ransomware that does encryption autonomously still needs to communicate the encryption keys that it used with a command and control server to say, hey, if this guy does pay up, here's the key that you're going to need in order to decrypt all of that stuff. And if it's unable to communicate, then presumably, if it's well written, it won't do the encryption. We have a few questions that have come in, so let's address those. One, I'm not exactly sure what it means. It says DNS forwarder to ISP. What are the best practices to avoid DNS forwarding to ISP? And then can we rely on an ISP forwarder for DNS security? And I think there the answer is in the vast majority of cases, the DNS servers that are run by ISPs are not designed or equipped to provide any kind of security. They might, in some parts of the world, in order to comply with local laws, prevent you from going to certain destinations. I know, for example, the Singaporean government provides a blacklist of sites that they deem to be inappropriate for Singaporeans to go to. There are lots of other countries that do things like that, but that's quite different from being able to identify, botnet command and control infrastructure, phishing sites that come and go all of the time. These are blacklists that are basically downloaded once every so often and updated once every so often, and there's no analytics. So I'd say that's a very different proposition. It obviously depends somewhat on the ISP. Different ISPs probably take this more seriously than others, but I would count on your ISP to provide that kind of DNS security.
Right.
Yeah. So somebody, Chris Richardson, who I think is one of ours, isn't he?
Yes.
He said, is BloxOne Threat Defense across DNS platforms available? He says if he's running Microsoft DNS servers here and Linux there and Unbound over there, can he use BloxOne Threat Defense as a centralizer or overlay to consolidate and secure all the outbound DNS traffic?
Yeah, absolutely. Right. So BloxOne Threat Defense can be in kind of that one layer above the other DNS servers that they're using. It could be Microsoft, it could be Bind, whatever it is. If you put BloxOne Threat Defense, it could be at the forwarding layer. So you're getting these DNS queries from the Microsoft servers or the Bind servers. You can still do blocking of bad DNS requests or blocking of data exfiltration on the BloxOne Threat Defense platform. The only thing is if BloxOne Threat Defense is not, or the Infoblox DNS is not close to the endpoints, you lose the endpoint visibility, but the customers can still get the protection, right? And all the great things that we have in terms of blocking all these threats. The only thing they would lose is endpoint visibility. So the best case scenario is to put it throughout the network as the main DNS servers, internal recursive DNS servers that are servicing all these endpoints and clients and end hosts. That way they get not just the protection, but the visibility as well.
Right.
Yeah, but of course we can work with Microsoft servers. We have integration, Microsoft management tool that works with whatever DNS server that the customer has. So, yeah.
Yeah. We should remind people that we'd love to get more questions from them so that we can answer them. That they don't have to be about BloxOne Threat Defense, but if they're not about DNS, I'm not sure what our batting average is going to be in handling them. Somebody did just write in to say, do you consider Cisco Umbrella to be a complementary offering or a competitor? And if it's complementary, how so?
Okay, so Cisco Umbrella is a competing offer. It's not complementary. BloxOne Threat Defense Cloud actually directly competes with Cisco Umbrella. As we talked about earlier, Cisco Umbrella, which is a SaaS-only solution, does not get that full deep visibility into the actual end host that's making these requests. Whereas because BloxOne Threat Defense is a hybrid solution, we get the better visibility, deep visibility as well. I know that we support DNSSEC, and I don't think Umbrella supports DNSSEC yet. So, we've seen some cases where people have experienced outages because of that. So again, I think Umbrella is it's great for what it does, but it's not a complete solution. The other thing is Infoblox is vendor agnostic, right? We allow our threat intel, our great cyber intelligence unit up in Tacoma creates a lot of wealth of information about threat indicators that we leverage in our solutions, but we also allow this threat intelligence to be put in other security tools that customers may have, right? Their Palo Alto boxes or their SIM solutions or endpoint security. Like we are not, we work kind of with the rest of the world, so to speak, kind of like Switzerland, So we are kind of vendor agnostic. So whatever environment the customer has, our threat intel can be leveraged across the board in the entire security stack, right? So that's another big differentiator for Infoblox as well.
Yeah, I think, it's been some time since I used Umbrella, but Umbrella doesn't do as much analytics on the back end as we do.
Right.
That's right. So they do, I think they mentioned something about data exfiltration, but yeah, I think our analytics algorithms leverage or has been developed, using several models and algorithms, like you said, entropy, n-gram, and a whole bunch of information theory concepts, right? And I think we definitely have a lot of patents for those algorithms as well. So I think technologically we can detect a lot more threats, including data exfiltration, but also DGAs and fast flux with our analytics algorithms. And yeah, I'm not sure if Umbrella is up to that yet.
Yeah. Well, again, we'd love to get some more questions from our audience today. Let me see. I have one question here that I hesitate to read because I honestly don't understand what it means. But let's see if we can figure it out.
All right.
It's working with dynamic DNS. How does high-capacity, secure, recursive DNS in the cloud work with dynamic DNS used for providing redundant internet service connections to a client?
That's a really tough question.
I'm not sure. I mean, when I think of dynamic DNS, I think of dynamic update, RFC 2136 for those of you at home, which is a mechanism that allows clients, like for example, computers running Windows operating systems, to automatically update their name to IP address mappings or IP address to name mappings or things like that,
right.
which is pretty clearly different from the meaning of this dynamic DNS used for providing redundant internet service connections.
Okay.
So I don't know what that is. Do you?
No, I haven't heard of that before either. So
I was.
It's one of those really tough questions in the exam that you don't know how to answer.
Yeah. Well, maybe we could bluff, come up with something else. Yeah. So again, we'd love to have more user questions from those of you out in the audience about DNS or other relevant topics, or of course.
I think one thing
BloxOne
that's
Threat
come
Defense.
up in the past, Cricket, we may have answered this in the previous coffee chat, but I think it warrants a repeat. I think is what about DOT and DO, right?
Yeah.
So how is that different from what we offer, and how should customers think about that?
Yeah. So DOT and DO are last mile encryption solutions for DNS. DOT stands for DNS over TLS, and TLS is the same encryption that's used in HTTPS. It's
right.
the S in HTTPS, right. and DO is DNS over HTTPS.
Right.
And they were both designed in order to address kind of a long-standing problem in DNS, which was that the communications between what we call stub resolvers, or you can think of as a DNS client, and the recursive DNS server that the client communicates with, that communications is entirely in the clear normally. And so it's subject to lots of things, right. Snooping, interception, spoofing, lots of possibilities like that. So both DOT and DO provide some very important functionality in securing that communication. One, it gives you data privacy. It makes sure that folks can't see what you're looking up and the responses that you're getting back. It also optionally can provide authentication of the server to the client, so the client can say, oh, this is really the recursive DNS server that I intended to communicate with, and conversely, you can authenticate the client to the server.
Right.
So all of that is important stuff. The implementations of DOT and DO, however, are a little DO in particular, are a little problematic. One of the first implementations of DO was in the Mozilla Foundation's Firefox browser, and what Firefox did when you were using DO was basically sent queries over HTTPS directly to Cloudflare. And Cloudflare runs, for those of you who don't know, 1.1.1.1 and 1.0.0.1, as right. well as a couple of other IPv6 addresses. It did that for name resolution purposes, right. to say, hey, I need to look up www.cnn.com. I'm going to go to 1.1.1.1 to do that over HTTPS, and I'm going to get a response back, and I'm going to go there. The problem is that when it does that, it's ignoring all of the local resolver configuration on the computer that it's running on.
Right.
So the browser is actually doing something different from what another application running on the same machine would do. And it's also sort of bypassing all of the local DNS policies that you might have set up. Right. So for example, if you had painstakingly plumbed response policy zones into your DNS infrastructure to prevent folks from accidentally going to known phishing sites, well, Firefox just went around you, right. and tunneled the DNS query over HTTPS out to Cloudflare and got a response back. And who knows whether Cloudflare knows whether or not this is a known phishing right. site or not. Right. Moreover, you have no real visibility into this. Right. If you're the IT organization managing the network on which this client is running, you don't even really know that this has happened because it's all encrypted over HTTPS. It's all gone out to Cloudflare. If you're an organization, say outside of the U.S., maybe some place that's covered by data privacy regulations, well, you've just given a bunch of telemetric data to Cloudflare,
right,
too.
Exactly.
So, and that may not be what you want to do. Now, I should say that DOE is not on by default in Firefox. It's something that you have to check a box to activate. But there's I think real concern that in some future version of DOE and some future version of Firefox, they'll just activate it automatically, and those of us who are in the business of building secure DNS infrastructure will have a lot of our work undone through this. And then there's the looming specter, if you will, of Google, because of course Google runs their own very popular cloud-based recursive DNS service, Google Public DNS, and they have a very, very popular web browser, Chrome. In fact, Chrome has a market share that's in the high 60s, I think, high 60%. So enormous compared to Firefox. Firefox, I think, is something like 5%. And Google has every reason, when you think about it, to make using DOE to Google Public DNS the default within Chrome, because of course they'd have so much interesting information that they could collect. Right now they collect a tremendous amount of information when you go to their search engine, but now they could get so much more because, as we've said many, many times, basically every non-trivial transaction that occurs over the internet is mediated by DNS or preceded by DNS. So that has us very concerned. We had a lively discussion of DOE last week in Washington, D.C. at a meeting.
All right, great. Those are really great insights, I think. I think it's top of mind now for some people, so I think it's good to address that.
Yeah.
All right, so do we have more questions?
Let me take a look and see if any trickled in.
Chat?
Yeah. I guess not.
Okay.
So
all right.
Perhaps we should wrap it up.
Yeah, we could wrap it up. Thank you so much, Cricket, for joining the session today. I think we'll continue to do more of these as well, but I think giving the audience the chance to ask questions live and help and us answering them live, I think is really helpful. So thank you so much.
Of course.
Yeah. And thank you to the audience for joining us today. This is a coffee chat, so all our attendees will get a $10 Starbucks gift card. So please go and enjoy your cup of coffee and join us next time for Coffee Chat with Cricket. Thank you.